My name is Filipa Ribeiro, and I'm a PhD student at the University of Delaware, and I'm a fellowship recipient of the International Foundation for Ethical Research. I work in Dr. Jason Gleghorn's lab, and my interest broadly is in microfluidics and women's health. The cervicovaginal region is a boundary in the female reproductive tract located between the cervix and vagina. It's vital for reproductive health and immune defense, aiding in pregnancy, menstruation, and infection clearance. Nonetheless, it is also a common site for STIs like HIV, gonorrhea, chlamydia, and HPV. So this cervicovaginal region is indeed incredibly dynamic and complex in nature, which makes it challenging to study. Gonorrhea is one of the most common sexually transmitted infections, and it can cause abnormal vaginal discharge, discomfort, and pelvic inflammatory disease, and when not addressed, potentially causing chronic pelvic pain, ectopic pregnancies, and even infertility. A key indicator of gonorrhea infection in the cervicovaginal region is the extensive immune cell recruitment to the site of infection. So these immune cells often fail to clear the infection, but we really don't understand why this happens. And so current methods of modeling gonorrhea and other infections in the female reproductive tract include 2D cell models, which lack the complexity of organs, and animal models, like mice, that have the complexity closer to the human body. However, these animal models have extensive ethical considerations and do not fully represent the physiology of the human female reproductive tract. Nonetheless, animal models are still the gold standard in research working on understanding these infections and therapies. So new methods that decrease the use of animals while preserving the complexity are needed to improve research outcomes. Microfluidic devices and organ-on-a-chip technology, which consist of multiple channels that are integrated on a chip that mimic the desired physiology components, can help fill this gap in methods while decreasing the need of animals in preclinical studies. So our lab has developed a microfluidic system that mimics the cervical region of the female reproductive tract, and my project consists of advancing this device to incorporate gonorrhea infection and human immune response, such as neutrophils and macrophages. So my inspiration comes from wanting to contribute to closing this gap and ensuring that women's health is studied with the same rigor as other areas of medicine. So by focusing on the cervicovaginal region, we aim to create models that can give us insight into how diseases like STIs affect this population specifically. And this work directly aligns with IFER's mission to develop and validate innovative scientific methodologies that not only advance science, but also replace the use of animals in research. We're working on a humane alternative because the female reproductive tract is incredibly complex and simply cannot be accurately modeled using animals due to anatomical and cellular differences. So our 3D model of the cervicovaginal region offers a more accurate and ethical way to study these diseases without the need for animal testing. Dr. Gleghorn has been vital in guiding me as we navigate the technical complexities and challenges of this project, and his expertise has been invaluable to the progress that we've made. And funding from IFER will support my academic journey by covering my tuition costs, allowing me to fully dedicate my time and support to this important research. So looking in the future, we plan to continue refining this model to explore how it can be applied to other areas of women's health research, such as the study of other reproductive diseases. And my long-term career goal is to lead research that innovates in women's health. And I'm excited to see how this project can contribute to better health outcomes for women and more ethical research practices worldwide. Thank you for your support, and I can't wait to share more as we continue this journey.